And let's begin. Am I sharing the right screen? Can you guys see this? Yep, cool. So we're gonna break down queries apparently today. Okay, we are gonna recap real quick on what you've learned so far. I think the first day of SQL queries this week, you wrote some very simple series, like one-line queries, basically. And then day two, we started to build upon that using from, join, and where to expand on these queries. Day three has us introducing group by and order by to further add some complexity to your queries. Basically, multiple columns can be selected from multiple tables using commas. And I guess this is referencing specifically group by. Once you've joined data from multiple sources, you'll want to use group by to organize that data. When you're using group by, you have to make sure that non-aggregate columns also appear in your select statements. So you see here in the very first line, we're also using the commas to separate the data that we've separated with a comma to match how we have in the group by line. I think you guys have already looked at database diagramming. And let me know if you haven't. Does that show up yep, that shows up in today's lesson. If you haven't been introduced to it yet, we use things like what's good database diagramming. I'm blanking on the name of DB diagrams, the one that we use, I think. There's a bunch of these online. Basically, they're ways to visualize the data that you're organizing into a database, and you'll be using these a bit more as you, specifically on Saturday, I think, as you start to plan out actual schemas for databases. But for the time being, we want to at least know what this is, what it looks like, and how to read it. Each little table references its own database table, with each entry here essentially being a column in that table. We can see how there are connections between different database tables using these little flowchart strings, and these are basically linked. So for user profile, the account ID will be read from the account ID in app user, and so on and so forth. So when we're writing, we talked about breaking down a query, but let's think about writing a complex query step by step. I'm a big proponent for standardizing processes. So if your goal was to query the total number of, let's say, each make advertised in each city, ordered by city for, let's say, a database full of cars, you're going to want to think through it in steps. Your first step is to be able to identify the tables that you're going to need. And then you'll want to plan how you're going to connect the data in these tables together. And from there, you'll write a starting query for all the columns needed with some kind of a reasonable limit. And then you review and revise and you repeat. So step one, let's say with our example of a car database, we want to be able to query the total number of each make advertised in each city, ordered by the city, and we use this info to identify the right tables. Since user profile in this example and car model tables are not connected, we can plan out a connecting path in between them. We know that the user profile will have an account ID. We'll want to be able to reference this account ID in the app user database because each user should have a user profile, and each advertisement should have a way of connecting to the app user. In this example, it looks like we have a seller account ID that is linked to the account ID of the user. Each user then is a seller who could create multiple advertisements. Each advertisement will tie to a car from the car database using a car ID, and each car will have a car model using a car model ID. So this is just an example of how you can plan multiple tables to represent this kind of data and link them together. As a starting point, we want to write a query that can confirm we have all of the columns that we need. So let's break down the query that we have here. We're selecting all from a table called user profile. We're giving it an alias called UP so we can reference it very quickly. We're joining the app user table, which we give an alias of AU. And we join these on the account IDs. You see how that matches how we were linking the account IDs in these two tables in the previous slide. You repeat this process until you've connected all the tables that you need, and then you have your query. So if we were working with like a real data and these databases had a lot of information, your query might run slowly because it's pulling a lot of information. So that's where setting limits comes into play. Or specifically, if you're running a query with a specific purpose or intent in mind, which is to maybe pull one result, that's another instance in which you'd want to set a limit. Right, this is an example of too much data for the eye to easily parse through. And that's where things like revising using limits can help make the data that you retrieve more legible. So in this example, we have used an aggregate function such as count to get a much cleaner result. And we can add the columns we want from the tables they're from using the group by statement. So here we are grouping by the city and we are grouping by the make. Otherwise, if we forget to group by our non-aggregate selections, the query will fail. And you'll get a very clear error, so it should be easy to correct. So all that's left to do is then to order by the column, 2 for count, and style ascending for ascending order. So here we have order by 2, ASC, and that gives us all of our data in alphabetical order. Any questions so far?
I have a question, although it's a little bit more related to the organization of how data is distributed across tables itself. So for instance, there's the diagram on slide 10 that has that overview of the different tables. And I was curious when it comes to user profile and app user, I was curious about why some of that user profile information is not included directly within app users. Is that more for like just better organization so that there's not too many attributes or entries within one table?
It really boils down to the use case, right? And how you as the software developer write your application and plan out to be like it's in this case, we can imagine that for whatever reason, these developers wanted the app user to be separate from the user profile. It's possible that the app user has the ability to create multiple profiles, or another plausible reason for dividing the information this way could be the user itself. The user itself is basically let's say the individual, right? And the user profile is more so the information connected to that user. Like a user should be able to change their profile information. They could be able to erase all that profile information, have a blank profile. It really boils down to the use case, the kind of functionality you want to build out in an app, because you also want to think ahead to things like the portal that the user is going to be interacting with. Where are these components going to live? Is the user going to be able to have the ability to change certain things like their first name and last name? Or it makes sense, for example, right, for a user to be able to update their address, but maybe we don't want that user to be able to change their name or their social security or their email or something like that. That all really depends on you as a developer and how you plan things out. Does that kind of answer that?
Yeah, that's helpful. Thank you.
Sure. I guess one last thing I want to add is also you'll want to be mindful and plan ahead for how the data is going to be queried and how the data is going to be used. So not just by like the user itself, but like let's say other software engineers on your team or people from different teams included, like business, for example. How are they going to run, or customer service? How are they going to be running the queries they need to gather the data that they need? So all of these questions come into play when you're planning out your database schemas. And I'm pulling up the Zoom chat. That's a good point by Noel. User profile could be the Netflix account. App user could be each profile on that account. That's a very great example.
Yeah. Yeah. Uh, I'm fine.
Okay, let's see. We going back to our slides. No, that was actually
I have
it.
a quick question.
Sure.
So in this case, I know just for these particular tables, could
Mhm.
we have skipped over app user just because account ID is the same for both of those, and then they would correlate to seller account ID?
Yes, but if you were then trying to query for information inside of app user, you may not be able to access it.
Gotcha. So if we didn't need anything from app user, then it would be fine, but otherwise.
Exactly. Cool. Let's see. So like I mentioned earlier today, when you go over SQL Part 4 on Saturday, you'll be thinking more along the lines of schema design. So you'll be doing a bit of diagramming. Today, though, we're still going to be working with breaking down queries and writing queries and getting some practice loading up your schemas through SQL scripts. You guys have already started running Docker containers with these databases, right? Okay, cool. Let's run through. I want to see what else do I have here. Optional code challenge. Oh, I don't know if we're going to do that today. That was for the last cohort. I guess we could if we wanted to. I think Jesus did find a very fun code challenge a few weeks ago that I'd love to share. So maybe I'll add that too if anybody needs even more to work on today. I'll Slack it to you guys. The second challenge will be to solve as many of the 12 PostgreSQL exercises as possible, and that's probably in the SQL School website. Yeah, and then when we get back tonight, we'll reconvene at 9 and we'll have everybody run through one of the exercises. I guess whoever volunteers first gets to choose which exercise they want to do, and then the remaining folks will have to demo one of the exercises that haven't been demoed yet. That's how we're going to play this game. Let's see. Optional code challenge. I think everyone hated this challenge last cohort, so I might hold off on introducing this one. Also because Jesus did find that really fun one a few weeks ago, so we'll save this for later. Now let's run over our README, see if there's anything that I need to demo for you guys. You'll be executing queries against Car's database, which I think you've already been doing. So you're essentially running that same Docker container. What else? We went over this. Yeah, I'll run through this demo on your own just to get a bit of practice navigating your tables. And I don't think there's anything here that's really new. You're going to be running through some of the stuff that we went over in the slides, like adding some limits, adding group by, and it should be fairly straightforward. You should be able to fly through this and get to the challenge afterwards. Any questions? Cool. Take a break. I will set up breakout rooms so they'll be ready for you when you get back, and we will reconvene at 9. And like always, just check back in the main room if you have questions. Cool.